The thermal energy transferred from a warmer object to a cooler object. Heat. Heat is the energy that moves from something hot to something cold. Imagine you're at a crowded party and one friend is monopolizing the conversation, talking nonstop while others barely get a word in. This scenario is similar to how thermal energy flows from a warmer object to a cooler object as the warm object dominates by transferring its energy to the cooler one. Just as the talkative friend transfers their conversation to a quieter group, resulting in a more balanced discussion. Thermal energy moves from the warmer object to the cooler one until both are at the same temperature, achieving equilibrium. The energy of the moving particles in an object. Thermal energy. Thermal energy is the heat generated by the movement of tiny particles within a substance. Imagine trying to keep a crowded room of excited children calm at a birthday party. Just like the energy and movement of these children bouncing around, thermal energy is the energy of particles moving within an object. The more the children move and the more excited they become, the more energy they have, similar to how faster moving particles in an object mean it has more thermal energy. The transfer of heat energy between two objects through direct contact. Conduction is when heat moves from one object to another by touching them together. Imagine you're trying to pass a secret note to a friend across the table without anyone noticing. Just like the note needs to be physically handed over to your friend for them to read it, heat energy transfers from one object to another through direct contact in conduction. In this analogy, your hands touching the note represent the objects in contact, and the secret message being passed from one person to another is like the heat energy moving from the warmer object to the cooler one. The transfer of heat energy from a warmer area to a cooler area in a liquid or gas. Convection. Convection is the process where warm air or liquid rises and cooler air or liquid sinks, creating a cycle. Imagine you're trying to cool down a hot cup of coffee by stirring it with a spoon. This is similar to how convection works, where movement within the coffee, like that of heat energy in a fluid, transfers heat from the warmer coffee to the cooler room air. Just as stirring the coffee helps distribute the heat more evenly and allows it to cool faster, convection involves the movement of warmer and cooler fluid particles, facilitating the transfer of heat energy from a warmer area to a cooler area in liquids and gases. A machine that converts thermal energy into mechanical energy. Heat engine. A heat engine is a device that turns heat into motion or work. Imagine trying to cook a meal using only the heat from a single candle. Just as you need to find a way to concentrate and utilize the candle's heat effectively to cook your meal, a heat engine works by converting scattered thermal energy into focused mechanical energy. In both scenarios, the key challenge is transforming a diffuse source of energy into a concentrated form that can perform work, whether that's making dinner or powering a vehicle. A material that does not conduct heat well. Thermal insulator. A thermal insulator is a substance that slows down the transfer of heat. Imagine trying to have a conversation in a crowded room where everyone is talking loudly at once, making it hard for your words to travel to your friend on the other side. This situation is similar to how a thermal insulator works, as it prevents heat from easily traveling through it, just like how the noise prevents your voice from reaching your friend. Just as the loud chatter acts as a barrier to your communication, a thermal insulator acts as a barrier to heat transfer, slowing down the movement of heat from one side of the material to the other. The transfer of energy by electromagnetic waves, it does not require matter. Radiation is energy traveling through space as waves or particles. Imagine you're trying to get someone's attention across a crowded room without being able to physically approach them. Just like you might wave your hands or use a flashlight to signal your presence from a distance, radiation transfers energy through electromagnetic waves without needing a medium like air or solid objects. In both cases, whether it's your signal reaching the other person or energy moving through electromagnetic waves, there's no need for direct contact or a physical intermediary. It's all about transmitting a message or energy across space. The amount of heat needed to raise the temperature of 1 kilograms of a substance by 1 C. Specific heat. Specific heat is the measure of how much heat energy is required to raise the temperature of a specific material. Imagine you're trying to fill a balloon with air and you notice that different balloons require different amounts of air to reach the same size. This is similar to the concept of specific heat, where different substances need different amounts of heat to increase their temperature by 1 degree Celsius. Just as each balloon has a unique capacity, determining how much air it can hold before reaching a certain size. Each substance has a specific heat capacity, dictating how much heat it requires to increase its temperature by a specific amount. How hot or cold something is, it is determined by the kinetic energy of its particles. Temperature. Temperature is a measure of how fast the particles in a substance are moving. Imagine you're stuck in traffic, and the flow of cars seems to dictate how long your journey will take. This situation is similar to how the temperature of an object is determined by the speed and movement of its particles. Just as the density and speed of cars influence how quickly you can reach your destination, the kinetic energy of particles determines whether an object feels hot or cold. Faster moving particles in a material mean higher kinetic energy and a higher temperature, much like a faster traffic flow means a quicker trip. An increase in the size of a substance when it is heated. Thermal expansion. When materials are heated, they expand because their particles move faster and spread apart. Imagine trying to squeeze into your favorite pair of jeans after a big holiday meal. Just like how your jeans feel tighter when you're full, materials expand when they heat up. In both cases, whether it's your waistband or a metal rod, adding energy from food or heat causes an increase in size as molecules move apart to make room, making it a perfect analogy for thermal expansion. The movement pattern in a fluid caused by temperature differences within the fluid. Convection current. In simple terms, a convection current is when warmer fluid rises and cooler fluid sinks, creating a circular flow. Imagine you're in a crowded elevator and everyone is trying to reach different floors. Just like people in an elevator move up and down to reach their desired levels, warm and cool parts of a fluid move in a similar pattern. As the fluid heats up, it rises, similar to people trying to get to higher floors, while cooler fluid sinks, akin to people heading to lower floors. This movement creates a continuous cycle, like an elevator's constant up and down motion, illustrating the convection currents caused by temperature differences within the fluid. The lowest possible temperature, 0K, 9°73°C, absolute zero. Absolute zero is the point where all molecular motion stops completely. Imagine trying to clean a cluttered room where every item is perfectly still and nothing seems to move, no matter how much you try to tidy up. Absolute zero is similar to this scenario because it's the point at which atoms and molecules in a substance have minimal kinetic energy and are essentially frozen in place. Just as a room can't get any more organized if everything is already immobile and perfectly still, a substance can't get any colder than absolute zero because its particles are at their lowest possible energy state, unable to move or rearrange any further.